your motive is the same. You are given a function fx. Your target is the same. You need to find out the minimum value, the point at which the function is getting minimized, and of course the value of the function at the minimum point. So you know your so if this is x star, your aim is to find this x star. This is what we have been doing actually throughout. So what we do is, if this is A and this is B, AB being the initial interval of uncertainty, let this point is xm. What is xm? If I write the algorithm, your first point would be to find xm, xm being the midpoint of AB, A plus B by 2. That is the midpoint of AB. What is AB? AB is the initial interval of uncertainty. Then what we do is, we would be finding two more points, x1 and x2. Suppose this is my x1 and this is my x2, where you know x1 is just the half of A and xm, and x2 is also the midpoint of xm and B. So what we can say is x1 will be given by A plus B minus A by 4. See, am I okay with this? What is B minus A? B minus A being L, if I call the initial interval of uncertainty as L. So this is how we are getting x1, and x2 is going to be, so if we can call it A plus L by 4, and x2 would be definitely B minus L by 4. Are we okay with this? We are finding out. The second part of the algorithm is, first we find out xm, then we find out the two quarters, that is x1 and x2. Next, we have to figure out the functional values. That is, we need to compute fx1, fxm, and fx2. These two need to be calculated, and then we need to compare fx1 with fxm and fx2 with fxm. Just a moment, let me close the door. So we need to compare all these values. Now, suppose this is A, B, this is x1, this is xm, and this is x2. Okay. Now, you know, it may happen that if I call The fifth one is comparing all the cases. If it so happens that f of x1 is less than f of xm is less than f of x2, that implies this function is increasing. Like this. Okay. Then what we can definitely say is the minimum is never going to lie in the region xm to b. Am I right? If this be the case, can I say this? That implies your interval is actually halved. Your new interval of uncertainty is going to be a to xm. Okay. The next probable case can be if f of x2 is less than f of xm is less than f of x1. This implies a x1 xm x2 b. This implies the function is decreasing, right? So if this be the case, we can also say on the contrary that your minimum will definitely not lie in the region a to xm. See, am I right? If it is decreasing, then your minimum can never lie in the region a to xm. So even in this case, your interval is halved exactly. Your new interval of uncertainty would be xm to b. And the third case can be, would you like to tell me what can be the third case which we have not considered yet? What can be the third case? Anyone? What can be the third case? Are you there? What can be the third case? Acha, ekta kotha bol, just tell me one thing. The function that we consider is monotonic, right? Every time the function that we are considering is monotonic, tar mane it has got a single peak or a single value. And since we consider always that the search algorithm is for minimizing a particular function, so we are interested in finding out the minimum value or the minimum point, correct? So we can assume that the third case can be when f of x1 is greater than f of xm, f of x2 is also greater than f of xm. Can this be the third case? That implies in the first case, it is monotonic increasing, this is monotonic decreasing. What I'm actually referring to is this is xm, this is x1, this is x2, this is a, this is b. This is how the function is going to look like. F of x1 is greater than f of xm, and the same is valid for f of x2. Would you like to tell me which region are we going to eliminate under this circumstance? এটা পারা উচিত কোন রিজিয়নটা এলিমিনেট করব? Exactly. We would be eliminating x1 and bx2. Eventually, the interval is again halved, isn't it? So your new interval is going to be x1 to x2. So these are the three probable cases, and we would be proceeding until and unless we reach the desired accuracy. The accuracy may be in terms of, you may be directly told that you need to perform 4 iterations. You may be given a tolerance. In this manner, the stopping condition will be mentioned. Say, for example, let us talk about a very small function. If I tell you to, if I tell you to maximize fx given by minus x square minus 54 by x in the interval 0 to 5, taking tolerance to be less than 0.2. Okay. This is what you need to do. You need to minimize this in using interval halving method. Acha, so please tell me, what is the very first thing that we are required to do? Ball. So far, the problems that we had done, we minimized the functions, correct? This is a problem where we need to maximize the given function. So what is the first step that we need to take? We need to convert the max. Exactly. We need to convert this to a minimization type problem, and definitely the problem would be minimize f star x equal to, it would be x square plus 54 by x. Correct? ठीक बोललाम? The rest all remains the same. So do remember, even if we are given a maximization type of a problem, we would be able to solve it using any optimization technique that we are being told. First point is converting the maximization type problem to its corresponding minimization type, then apply the method accordingly. So once we have converted this, this is, please pardon my lines gulo. This is a equal to 0. This is b equal to 5. These are the points that are given to us. The midpoint is going to be 2.5. This is our xm actually, to be precise. If I call it x0, this is my x1 and this is my x2. So what is x1? What is x1? What is x1? It's 0 plus 2.5 by 2. It's 1.25. And what is x2? It's 2.5 plus 5 by 2. It is 3.75. Thick? Am I correct? Okay. So we need to calculate. X1 is given by 1.25. X0 is given by 2.5. X2 is given by 3.75. So we need basically to calculate f of x1, f of x0, and f of x2. Would you like to tell me what are the values? F of x0. 0.85 and f of x2 correct. So don't you think that এখানে কি হচ্ছে f of x1 is more than f of x0, f of x2 is also more than f of x0. So which region do we consider in the second iteration? তার মানে the ফাংশনটা এরকম দুদিকেই বাড়ছে. So you're correctly pointed out. Now your A is 1.25, your B is 3.75. Right? If this was our L0, this is our L1. We need to carry on. The stopping condition says we need to carry on till the interval of uncertainty is less than 0.2. যেটা প্রবলেমে দেয়া আছে. So if this is definitely more than 0.2, there's no point calculating. So this is 2.5. We are calling it x4. This is let us calculate x3, x4 হচ্ছে 2.5, x5 are the values 1.875 and this is 3. ঠিক লিখলাম. Am I okay with the calculation? So we would be calculating f of x3. What is f of x3? It's precisely 32.3156. F of x4, which is 27.85. F of x5, which is 27.0456. Am I okay with the calculations? Am I okay with the calculations? What? See this, nobody interacting. Anyways, so if this be the case, we have f of x3 more than f of x4 more than f of x5. So the function is actually decreasing. The function is decreasing. So in the next step, we would be eliminating this region. So what do we have? It's 2.5. We can call this one as L2. x5 and x8. 5. So what about the points? What is x7? x7 is 2.8125. x6 is 3.125 and x8 is 3.4375. f of x7 is 27.11015. f of x6 is 27.0456. তোরা কি ক্যালকুলেশনস গুলো করছিস না করছিস না? দেখ তো এই অবধি ঠিক আছে কিনা। এখান থেকে what can we conclude? We have f of x7 more than f of x6, তাই তো? We also have x8 more than f of x6. তার মানে ফাংশনটা kind of it's like this. So again, like the first iteration, we need to eliminate 2.5 iteration number 4. Your A is x7 money 2.8125. Your B is x8, that implies 3.4375. What is the midpoint? x9, x10, x11. যদি এভাবে ভাবি, x10 is the midpoint. x10 is given by 0.125. x9 is A and x10 er midpoint, so it is 2.96. না করতে হবে না, ঠিক আছে, 3 প্লেস অবধি রাখলেইছি না। x11 is going to be the midpoint of x10 and B, which is 3.28125. So now we would be required to calculate f of x9, f of x10 and f of x11. তো তোরা কেউ গুগল ক্লাসরুম চেক করেছিস? অ্যাসাইনমেন্টের ডেটটা আছে টিল 31st জানুয়ারি, অনেকদিন সময় আছে, 20টা অঙ্ক আছে মাত্র। আর তাতে তোর এই 20টা মাত্রই, তোদের কাছে কোনো ব্যাপারই না। আর সেখানে আমি এই 4th মডিউলটা ইনক্লুড করিনি, মানে এই লেন্দি প্রবলেমস গুলো নেই। What we have is ওই শুরুর দিকের পার্টটা, মানে এলপিপি ট্রান্সপোর্টেশন অ্যাসাইনমেন্ট, ঠিক আছে তোরা করে দেখ। তোদের গেটটা তো প্রবাবলি কবে, ফেব্রুয়ারির কত, ঠিক আছে দেখ কতটা কতটা কি হয় দেখ। তো যাই হোক, এখানে উই নিড টু ক্যালকুলেট এফ অফ, আচ্ছা আমার আর আই নিড ওয়ান মোর ক্লাস টু ফিনিশ অফ ইউর সিলেবাস, জাস্ট ওয়ান মোর ক্লাস। সেখানে we have nothing new to study. We will be checking on another stopping condition for dichotomous search algorithm, which is very important for you people to know. So I just need one more class where I'll be discussing about one such stopping condition for dichotomous search algorithm. Tahole your syllabus would come to an end. So I just need this Friday's class only, the last meeting with you, where we would be discussing about that part, and that would mark the end of our syllabus. Anyway, what about f of x9? It's probably 27.003. বেশিক্ষণ সময় নেই। 27.003. f of x10 is 27.05. Our f of x11, 27.224. That implies we have f of x11 more than f of x10 more than f of x9. তার মানে ফাংশনটা হচ্ছে বেসিক্যালি ইনক্রিজিং, রাইট? Increasing function. So without any doubt, we can eliminate the region from x10 to b. এক মিনিট। Okay, so we have this portion being eliminated. So in your next iteration, what do we have? We have this a is as it is. It's কত হবে a? 2.8.25. Your b is x10, মানে হচ্ছে 3.125, right? আর L2, this is L3, this is L4, ঠিক তো? L0, এটা L4. I call this one as L4. L4 টা কত হচ্ছে বলতো? 0.31. তার মানে হচ্ছে যা বুঝতে পারছি আর একটা ইটারেশন করলে আমাদের হয়ে যাবে, বিকজ স্টপিং টলারেন্স হচ্ছে আমাদের 0.2 এর থেকে কম হতে হবে, the interval of uncertainty, right? আচ্ছা, তো এখান থেকে we need to calculate, this is x12, x11, so 12, 13, 14, x12, x13, x14. x13 হচ্ছে দুটোর মিড পয়েন্ট, x13.96875 precisely. x12 হচ্ছে এই দুটোর মিড পয়েন্ট, so it is x12, 0.8906, perfect. And X14?
3.68.
3.0469.
6875.
6875. So we would be calculating f of x12, f of x13, f of x14. Values gulo. F of x13 কত ছিল? 27.003. Or f of x14? F of x4. Acha. So ekhane abar what we figure out is f of x12 is more than f of x13 and f of x14 is also more than f of x13. So we would be eliminating a to x12 and x14 to b. That would imply your new region is going to be A hoche x12, which is 2.8906. Your B is x14, which is 3.046875. So what about L5? L5 is 0.156, which is definitely less than the tolerance, which is 0.2. That implies we have come to an end. And what is x optimum? The midpoint of this interval. To get a better value of the optimum, we take the average. So it is 2.8906 plus 3.046875 divided by 2. কত হচ্ছে? হ্যাঁ, সেটা হচ্ছে x13. 2.96875. আচ্ছা, জাস্ট এখানে একটাই ব্যাপার বলার, we need to calculate f optimum. এখানে কিন্তু f optimum কি, we actually the need was to maximize the given function, so it is going to be minus x optimum square minus কত ছিল 54 by x optimum. So calculating this is going to give us the answer. This is the answer that we want. Okay? একদমই তাই, হ্যাঁ একদমই তাই। কিন্তু এটা ভুলে যাস না যে আমাদের মোটিভ কিন্তু এখানে যেটা স্টুডেন্টরা জেনারেলি করে, ওই পজিটিভটাই রেখে দিল ওরা। হয়তো লাস্ট মোমেন্টে সেটা আমি তোদেরকে মনে করিয়ে দিলাম যে আমাদের মোটিভটা কিন্তু ম্যাক্সিমামটা বার করা, এখানে কিন্তু মিনিমামটা আমাকে বার করতে দেয়নি। এই লাস্ট চেঞ্জটা কিন্তু করাটা ইম্পর্টেন্ট। ঠিক আছে, ঠিক আছে, চল দ্যাটস ইট। আর একদিন নেব আমি ক্লাস, সিলেবাস শেষ হয়ে যাবে।